interesting. Just to
So they're all.
Got it.
What do I need to end up had to dip into their own comments? They tried to, they took one after the lawyer. Even tried to.
Thank you.
Anyways, like the lawyer guy.
thanks, Pam. Now, all right.
Well,
Start again. Good afternoon, and welcome to our panel. We're going to be talking about some issues relative to water and agriculture this afternoon. I'll just want to clarify, I'm moderating. Your real panelist and expert is Jordan here next to me. And so he will be sharing a whole bunch of information, and I don't know about you, but I've got a ton of questions for him. But by way of background, my name is Jordan Formo, and I'm the Executive Director of the Minnesota Agricultural Water Resource Center. And so what that is, we're a coalition of ag organizations, including Minnesota Farm Bureau and about 20 others across the state of Minnesota. And for the last 20 or so years, I've been working on water issues across the state, working individually with farmers or with those farm organizations to address pretty much anything from drainage and wetlands to irrigation to feedlots to pesticides, you name it, nutrient management. We do educational programs and interact with farmers about those topics, and then also interact with state and federal agencies where there are programs that we can help shape to make sure they're working appropriately for farmers, or to weigh in and provide feedback on regulations and those sort of issues. So I'm really excited because my background is mostly around traditional crops and livestock operations in Minnesota, and so I'm really eager to learn more about this topic of controlled environment agriculture. I think we're going to talk especially about today when I look outside. The idea of controlled environment agriculture is very appealing. So joining me today is Jordan Bergstrom from the University of Minnesota. Welcome, Jordan. And let's start by welcoming him, and then I'll ask that Jordan give a background for himself and the program.
Well, hello everybody, my name is Jordan Bergstrom. So a little background about me, I'm a very recent convert to urban farming. So my experience started back in 2021, came from a planning background, similar to some of the folks who were up here before. But yeah, I, in the planning spheres, I kept hearing about urban agriculture, vertical farming, particularly in regards to creating resilient cities and communities in the face of the changing climate. So I thought it was interesting, so threw my name in the hat for an internship up at the Fond du Lac Reservation, and ended up working there for a summer, managing a tribally owned organic farm up there, which was pretty daunting, but it was a great experience. Some kind of conventional agriculture, so in the field. And then subsequently got a job at Spark Y, a nonprofit in Northeast Minneapolis, which has given me the opportunity to work with a number of folks in the audience too. Yeah, and that there I was a sustainable systems manager, so working on some aquaponic systems in the schools, some urban farming beds, as well as a number of kind of city works projects, pretty varied repertoire. And then that finally led me here to the U of M. So currently I'm working as a lab tech for Dr. Nate Nalens, who's a new controlled environment agriculture professor here at the U. So I guess it's probably easiest to kind of clear up that term, controlled environment agriculture, as it's kind of being thrown around a lot and tends to mean a lot of different things too. So when we say controlled environment agriculture, it means a pretty broad spectrum of environmental control, ranging from working under like shade houses and high tunnels at the lower end, all the way up to growth chambers and kind of highly, plant factories, highly controlled, and every aspect of plant growth is provided by like a human input. Currently my experience is mostly in towards the growth chamber and greenhouse side, so a little more high tech than some other things, but yeah, it's all of that's kind of encompassed in that term too. Yeah, so I guess I can also go into some of the things we're doing at the lab currently as well. So we're involved in a wide variety of different projects, kind of ranging from different aspects of controlled environment agriculture. So within that term, we're mostly focused on hydroponics, which again is another word that's been coming up quite frequently recently. For those who aren't aware, hydroponics is growing plants in soilless or minimal soil conditions. So we tend to use rock wool and oasis as soilless medias, and then grow them in a nutrient solution mixture that's either recirculated or drained to waste. And that's kind of the big connection to this water use panel too, is our role and our kind of mission within our laboratory is to try and leverage these technologies such as hydroponic growing to reduce water usage in growing specialty crops like vegetables and fruits, which there's a lot of talk and it's different in practice than it is in theory too, and so you run into a number of roadblocks as far as water usage and having to, especially when there's disease outbreaks or that kind of thing, or nutrients get out of whack, we're having to drain a lot. So we're just working through leveraging different technologies such as automation or better environmental control to minimize some of those issues. I guess, sorry, back to you.
So, a question, we're talking about urban ag here, and the technologies that you're talking about generally allow a lot of agricultural production in a relatively small space. So could you talk a little bit about some of the subsets? I think for definition purposes, many of us are so new to whether you talk about aquaponics and hydroponics and all of those different areas. Could you just help us understand, what are some of the trends you're seeing in urban ag and how those different areas are growing?
Definitely, while hydroponics and aquaponics and in-ground urban farming and raised bed production, while they tend to kind of occupy those same spaces of urban agriculture, they do kind of represent two different veins of production. Hydroponic and aquaponic technology is more so leveraged for larger scale commercial farms aimed at maximizing output and potentially using more resources to do so, with the idea of lowering the amount of resources per unit that you're producing to increase efficiency. It is put kind of at odds with urban agriculture as well, as I'm sure a lot of you have heard and kind of experienced some of that tension between, especially the organic movement and hydroponics as well. That the kind of in-ground conventional farming is a lot more interested in providing or increasing accessibility of farming for more common people too. So people who don't necessarily have a background might live in an area where agriculture isn't present. So that's been a big challenge too with our field and controlled environment and hydroponics is, while any sort of farming requires a huge upfront investment for, equipment, materials, and labor, hydroponics and controlled environment, that's getting scaled up by a huge factor as far as, building greenhouses, infrastructure, building the hydroponic systems and running them too. And so there is a lot more at stake when you're talking about production and a lot of these really high input and high investment firms, which is partially why a lot of the commercial firms haven't been super successful recently. But so it's that's a big challenge, and I think a big potential focus for hydroponic farming and controlled environment is developing resources for people in the public and especially youth too, to try and develop a lot of the urban farmers to be able to work in these type of environments too, and provide a return on investment that we'll make it sustainable for them to be in that field for the upcoming decades. Within, and I'm sorry, you mentioned aquaponics too, but so just as another definition too, within hydroponics, there's, multiple different types of production too, and different systems you can use. So some range from a big basin of water that you're growing plants in a floating raft on the top of, to other ones where it's a small stream of nutrient solution that's going down a channel. Some of them are as simple as putting a basin of water in the bottom and having a wick that's going up into the soil to provide moisture that way. And aquaponics in particular is a method that utilizes both aquaculture and hydroponics too, and sort of marries the two. So you're using the fish waste and nutrients produced by growing fish to provide nutrients for the plants that you're growing as well. And it is pretty complicated as far as, you're not going to be able to perfectly predict what, the fish are going to produce as waste too. And so there's a little more, and they also sometimes don't have the necessary nutrients for the plants that you're growing too. So it requires a little bit of doctoring to make it optimal for the plants that you're growing, but it does also have the added benefit of producing fish at the same time too.
So I want to also, why don't you just hang on, I'll yell. So I also want to make sure to include some of your questions. So does anybody have a question as we've been starting our conversation up here? If not, I'll come back to you. You have it?
Yeah, it's like you touched on like some of the bigger, like maybe tech startups and all this scale. It's like, there's big investment, but is it, the execution is not good? Is that what you were saying?
So
Do we need to repeat the question for those?
Yes, please.
Okay.
yes, definitely. So the question is kind of delving a little more into why some of these startups are going under and what the reasoning and some of the why that's happened. So I think a big chunk of it is, I think the largest aspect is just that there's not a whole lot of institutional knowledge or a whole lot of precedent for hydroponic production. So similar to any kind of tech startup or new market that you're getting into, there's not too many people you can go to ask questions, or people to resources from which to kind of build your operations. So there's a lot of trial and error involved. I think the other side of it too, and something that Nate, the professor I work for, he always says that you're putting a lot of this capital in place, and you're trying to pay it off with a crop like lettuce or something that's not known for having a huge return on investment, which is partially why you're seeing a lot of it popping up within cannabis too, and other kind of high value crops. So that's proving a little more effective. But yeah, I think it's a combination of the two. So just not having that sort of societal groundwork, and the programs like controlled environment programs, resources, coupled with sort of a lot of these startups will try to do a little bit too much too, and so they're buying things they don't need. They aren't really focusing on the end goal, which is like keep your costs low and make sure you're producing what you're supposed to produce too. And yes, I think I think it's something that needs both help from the academic sphere and sort of policy sphere, but also just needs some time to iron out the kinks as well, and be allowed to evolve and move forward.
Question over here.
About 15 years ago, I started researching, hydroponic gardens and in controlled environments. And I'm not a scientist or anything, but I was looking for white papers and information, and the only thing I could find is like stuff from the 1940s from the Department of Defense. But is there any information which I would like to have in writing a business plan as far as pounds per square foot in these controlled environments? I found some sources, and it's like 18 pounds a year per square foot. Is there a source to get technical information?
Yeah, especially, yeah, I'm sorry, so I'll repeat that question too. So, the question is, in lieu of, there aren't a whole lot of white pages or SOPs or information on how to, implement these vertical farm, or implement, hydroponic farms. And so, kind of where are there good sources of information to go off of, or other good baselines? And somewhat of a tangent too, but you mentioned that a lot of the current resources come from the Department of Defense too, and that kind of harkens a little bit to the history of hydroponic cultivation too, which was initially used as a method to grow food for the U.S. military in the South Pacific on a lot of islands where, it's a lot of limestone soil, it's not very good, or a lot of places there isn't soil to grow crops as well. So that was a big, somewhat of the origins of this trend. But yeah, you're right. Since then, there's books, there's a lot of kind of anecdotal websites, this and that. But yeah, there's not a whole lot of real concrete figures from which to base a lot of these on. And that does lead to a lot of issues with greenwashing, with companies having some flexibility in what they're reporting and how efficient they're actually being. I know especially for water use efficiency, there's a figure of hydroponics being 90% more efficient than conventional farming too, which gets cited a lot. And I think the bottom line is it just really varies on your setup. It varies on how much water you're putting in, what crops you're growing, what your inputs are too. And so, as far as like theoretical potential yields go as pounds per square foot, there's not really a good figure currently to base that off of for creating a business plan too. So that's part of what our mission is here for the Controlled Environment Agriculture program at the U. Is we're trying to get some of that applied knowledge and start to build up a wealth of academic resources from which to base business plans on. And then that connects back to why a lot of these companies aren't failing to thrive and aren't be able to get off the ground too. Is they base their plan off of figures that they've heard from other people, and in practice it just doesn't work out the same, and so they end up going under. But I think probably your best bet for learning more about hydroponics, and if you want to kind of get into that sphere, is going off of different like published manuals, and I think a lot of those Department of Defense things might be good too. But as far as figures go for output, I don't know if I'd recommend basing a plan based off of the figures that they cite, just because it's so variable.
Just to kind of touch on that subject alone, because like I do hydroponics and small scale aquaponics, there's a lot better research coming out of different countries than the United States itself. Like if you look into Taiwan, Vietnam, Ecuador, Brazil, like they have a lot larger scales where they're doing it a lot more efficiently than we're seeing here in the States.
All right, well, thank you for adding that. And so we've talked a bit about water use, and that's something I wanted to have us delve into a little bit. And we know it takes water to grow stuff. And I don't know, I'll preface my question by saying I don't know what a lot of water or little water is. We're in a state that gets about 50 trillion gallons of rain a year. That's a lot of water. I know that's a lot of water. But I don't know in the context of hydroponics and that sort of thing, what's a lot of water? Maybe it doesn't require much water. But could you talk to us a little bit about the water requirements, and then along with that, are there bottlenecks or potential restrictions or shortages that people encounter as they try to do hydroponics?
Yeah, definitely. So yeah, as you mentioned, we're blessed in our state. Well, it wouldn't seem so based on the past 3 or 4 years of drought, but we tend to have far more water resources than a lot of parts of the country, particularly areas where a lot of our produce is grown too, such as California and the Southwest. Getting on like water usage as well. So one of the advantages and ways that hydroponic cultivation and controlled environment in general can improve water use efficiency is just by keeping water within the same system. So as opposed to conventional farming, where you're watering the soil, which a bit is going to go to the root zone, but a lot of it is going to infiltrate the soil or run off. The benefit of hydroponics is keeping it within a recirculating system. As far as usage goes, it depends on how much you're going to put in. So currently the ones we have roughly 120 gallons within the whole system. For our deep water cultures, quite a bit less for our channel ones, which those ones only require 40-50 gallons. Then apart from keeping the water in a closed loop, another aspect of that too is managing evaporation, managing transpiration by the plants too, so the water that's being released through the leaves in part to get nutrients throughout the plant, as well as also facilitate them breathing, regulate temperature. There's a lot of kind of higher tech solutions for that too. So a lot of people are using dehumidifiers to manage that water that's being transpired or evaporated and recirculating that back into the system. A lot of those are fairly expensive though in practice, at least on the scale that they're using them. And then also you want to balance that too, because there is also an optimal relative humidity level to maintain for the plants that you're growing to. Definitely, as far as water use efficiency for hydroponics goes, the root of it in its most basic form is fairly water efficient. The big issue comes with disease pressure, as well as kind of imbalanced nutrients too. So with it being in this nutrient solution, there's not a whole lot of buffer, if you're over fertilizing the plant's growing directly in that water too, so its roots are just going to get fried by the too high of a salt concentration. Alternatively too, if you don't fertilize enough, there's nothing in that solution that's going to be usable for the plant too. So disease pressure too, especially for us, has been an issue as well. So managing Pythium and Phytophthora and other fungal diseases and bacterial diseases. One interesting thing that we're working on too is utilizing what's called plasma activated water. So basically, the closest thing to describe it to is like when lightning is hitting a lake or a body of water in nature, it's in this state of matter that's not really one of the three basic ones referred to as plasma. And so along the way, it's picking up a lot of ions from the atmosphere, and then when it touches the water, it supercharges the lake or the ocean with the ions from the atmosphere. So it increases the mineral presence in the water, but it also drops the pH too, both of which are good, especially the pH is good for kind of minimizing the disease pressure as well. So, and another benefit to it as well is the process kind of generates I'm sorry, I'm forgetting the name of the acid it generates too, but hydrogen peroxide, which is a great tool for managing those diseases in the systems too. So that's something that we're working on to utilize that within the systems to both provide minerals for the plants, to lower the pH to an acceptable level, and also to minimize disease too.
So you talked a little bit early on about capital requirements and some of the challenges. Here in Minnesota in particular, so is access or availability or abundance of water a concern? or is there just plenty of ready access to water?
Yeah, so yeah, currently that's not a huge issue so far for Minnesota. Yeah, again, it's dependent too on the year rate and the water resources available, but for the most part, yeah, we're not seeing a whole lot of those kind of, yeah, like water usage requirements. Definitely not as strict as you're seeing in other parts of the country. But again, that's all changing and kind of up for grabs too as the climate changes as well. So major issue for in-ground production with rising temperatures is that the atmosphere is able to hold a lot more water than it used to. So, you know, while we're seeing more rainfall in parts of Minnesota, there's more potential for that the water in the soil to evaporate. And so we're not actually seeing as much water in the soil, and that soil water holding capacity is going down. Yeah, and you know, with that comes more requirements for irrigation too. And so that's, yeah, another kind of benefit to looking into this technology as well and seeing if there's ways to, yeah, kind of, you know, grow in a more controlled setting too, where you're not having to contend with those issues, especially in the future if water starts becoming more rationed too and not as abundant. Yeah.
So, and earlier you talked about a range of controlled environment technologies, you know, from fully controlled indoor to just extending the season with things like high tunnels and the like. And so, thinking about that range of, you know, very small, very large operations, typically do these enterprises use municipal water or their own wells? Are there any restrictions around or requirements for what kind of water they can use?
Oh, definitely. Yeah, that's a good question, especially in regard to the, you know, there's a lot of popularity of using gray water for agriculture as well as kind of reclaimed water. Yeah, so most hydroponics especially uses municipal water. That's what we're using currently. There's some issues, especially if you're doing aquaponics too, like making sure a lot of the municipal water has fluorine added too, so you don't want to be adding that to fish production or anything. But for the most part, for plants, it's pretty safe too. But yeah, yeah, when working with reclaimed water though, it's you got to be kind of careful because there is always going to be a risk of disease. There's going to be risks of heavy metal contamination too. So yeah, really, if you're using reclaimed water, the only way to guarantee that that's going to be safe biologically, well, and then also you know, not going to have those minerals in it, is to get it lab tested, which is pretty expensive. But yeah, it's worth it too if you're trying to keep like E. coli and salmonella out, or lead and cadmium too. Yeah, which is also another benefit to growing in hydroponics as well. While this can be mitigated through in urban agriculture through raised beds too, you know, you can keep the plants don't have as much access to those contaminants in the soil. You can be definitely sure in a hydroponic system too that those aren't going to be brought up and then added to the plants that you're growing.
Questions?
Yes, right here. What considerations would you make for disposing of spent water at the end of the growing season?
Oh, sure. Are you talking specifically for hydroponic or cultivation?
Hydroponics.
Definitely, yeah. So the question was considerations for water disposal, which touches on, yeah, another good issue. So similar to in urban agriculture and other types of agriculture, unused fertilizer and water is going to result in runoff, which is going to pollute streams, cause eutrophication and other issues. Yeah, and toxic algal blooms. And so, yeah, hydroponics isn't immune from that problem either, especially when you're dumping it down the sewer. It's all going to go to the same place that any other type of agriculture, their runoff's going to go to. But one unique benefit too within hydroponics is the ability to manage your wastewater too, because it's all going to be in a controlled system. So this isn't leveraged at most firms, or especially most farms, but there was some research done at the university on using algal cultivation to treat a lot of that wastewater too as it's coming out, which I don't think has been utilized yet in the broader sphere, but is also an option and is also kind of a benefit too, as far as releasing that water. But yeah, aside from that, I don't think there's too many. It's going to be comparable to agricultural runoff as well. So it's kind of the same problem, and yeah, it's just needs some creative solutions on that part.
We have a question in the back.
Yeah, so George,
But yeah, something.
have y'all like been playing around with like biochar or anything of this when it comes to filtration? And also, I know you guys do a lot of lab work with students at the Spark By Station and other places throughout the cities. And I'm really interested in the aquaponics stations that were set up in like Roosevelt and other places. But has there been any like tests done like what's going on in Flint, Michigan? I guess they've been working with like the water jugs, the 20-gallon jugs, I think they are, and then filling them up with the certain type of levels of earth filtration systems, having that bleed through in order to clean the water inside of Flint, Michigan. But with that said, are these different measures that have been practiced at a university level, what people are trying to do just at a civilian level?
No, that's a great question too, and Cliff was bringing up a lot of the municipal water concerns too, and water quality. So specifically in Flint, but common in a lot of other communities too, especially even to some extent here in the Twin Cities. And then kind of utilizing biochar and other earth filtration methods to clean the water as it's coming out as well. And specifically, I think, at the university was getting involved in that too. And at the moment, I don't think I'm not aware of any initiatives going on dealing with that water filtration. That is also an issue too for both hydroponics, but also urban farming as well too. Is you gotta make sure you know where that water's coming from and what's being added into it. And so even at the municipal level too, or depending on the pipes and what you're seeing, there's going to be some contaminants as well. That's a great point, and that's not something I've heard about or read too much about too, as far as using that earth filtration as well and biochar too. So I'll have to look into that as well. But thanks for putting that on my radar.
And like a more of a rhetorical one, where like how Zach and I are, Zach, the executive director of Spark Y, are exploring Earthship concepts and using the Earthship systems that Michael Reynolds has founded in Taos, New Mexico, around the world. And as we're looking at water filtration systems for Pillsbury United Oak Park, where Project Sweetie Pie is really based at, for the backyard urban farm, we're looking at like what does it look like to even lead our society towards water harvesting, working with biochar and cleaning roof water and putting different type of shaded tanks and practicing with that. But like, is this a talk that's even going on in any of the circles that you're sitting in? This type of sustainability acts.
Currently not so much. A lot, especially with Earthships. For those who aren't familiar, that's just the it's trying to come up. Got someone excited, but that's kind of going into housing, and finding ways to create systems within housing that utilize harvest rainwater, utilizes kind of passive solar technology to straw bale stuff, kind of to passively make a good living environment too, and coupled with other aspects of sustainability. That's not currently something that we're working on as far as Earthships goes. I'm not familiar with any other university program working on that, but the closest thing that is coming down the pipeline for that is work on deep winter greenhouses. Some of those greenhouses that are utilizing both insulation and passive solar techniques to grow food in a greenhouse with minimal energy inputs as well. Yeah, so that project currently hasn't got off the ground quite yet as far as our involvement. But yeah, that's something that we're gonna be looking into, trying to make that work as well, and exploring, if, you know, yeah, kind of how we make that work and what the parameters are, that sort of thing. But yeah, thanks for putting that over here.
So I have a question that overlaps a little bit with some of the land access issues, right? So while there's efficiencies and gains in reduced water consumption, you still have to purchase and maintain or lease and maintain a building, which is a huge cost, right? So, so I suspect that's a big part of the ones that haven't been successful, is just that chunk of their budget. But what buildings are or are not an ideal condition for this, especially when you're talking about the humidity that's introduced into an indoor environment? Like, is it maybe reasonable to convert an empty strip mall, but not reasonable to convert an empty office building? We've got a lot of empty interiors.
Yes. Yeah. So yeah, this is a great question as far as land access specifically in regards to hydroponic farming, controlled environment, agriculture. So yeah, that was something. So kind of some personal experience at Spark Y. We were growing. We had an aquaponics system within our office, which was in a kind of a repurposed industrial building or kind of the Cascade Arts building in Northeast, if you're familiar. But yeah, I mean, it was, the conditions for it were pretty tough because, you know, it's an old brick building, so it's getting all this air flowing through, which causes the temperature to fluctuate in the winter. The humidity was non-existent. Everything kind of just got sucked up by the all the dust and that's a huge challenge for as far as converting different spaces too, and also a critical aspect of planning a hydroponic farm that people don't always consider too, because it is a benefit of, you know, you're able to do it in places where you normally wouldn't if there isn't soil access, but yeah, really. I'd say with every step you get removed from nature, you know, it's just going to keep adding to your costs. So just to keep that in mind with your production too. So like, you know, if it's going to be in an office building or in a strip mall that doesn't have any light, doesn't have good insulation or good humidity inside of there, that's just going to be more capital that you have to add into that, which is why a lot of the firms that are more long-lasting will go a greenhouse route too, which a lot of them are doing further out of the cities. For example, I know probably you all are familiar with Bushel Boy and Rebel Greens too here in Minnesota, but they do a lot of their work on Owatonna and elsewhere in the state too. And yeah, I think that's another component that, because I think a big draw to hydroponics and controlled environment agriculture is the potential for having that in like a vertical setting too. So, you know, stacking farms on top of each other, being able to do that in downtown areas or dense areas, which is an interesting concept, and I think, you know, something probably worth exploring at some point. But, you know, another side of that too is, you know, you got to think through, you know, how much resources are you spending to produce things here in this downtown area, and then, areas where there's more beneficial land uses for it too, you know, like, especially if you're talking about office building downtown, you know, that's prime real estate and could generate a lot of other money in other areas too. So, you know, if you're doing that production on the outskirts of town or somewhere that's close but not necessarily right in the heart of it, I think that's something that gets overlooked a lot of the time, and unfortunately with urban expansion too, that land's, it's not cheap anymore either too, and a lot of those farms are going for millions. But yeah, that's a really good question too, as far as land access goes.
Way in the back. Thank you for your patience.
Me?
Yes.
Oh, yeah, I thank you for your wealth of knowledge. I'm actually with East Phillips Urban Farm and an architect, uniquely in this room full of agriculturalists. And one thing that from the outside looking in, I think to Cliff's question, which was a really excellent one, is this perpetual kind of question that keeps cropping up around harvesting water and using rainwater, either in a closed system or a controlled environment or even outside. We know Mississippi Watershed Management Organization, one of the biggest, kind of most important organizations in this space. They have a huge tank outside of their headquarters in Northeast that they're not allowed to release any of that water to the public where the public would be able to touch it due to toxicity. And I think your lab and your research is actually at the perfect fulcrum point to start to bring this critical point to kind of the forefront, because one of the biggest barriers to access when you get a piece of land, whether it's urban or not, is getting that water supply hookup. And I know from the case of Little Earth, right, the water supply from the city has not got a great profile for nutrition for growing their plants. And they respond to your earlier points about the ionization, and the rainwater is really what's supercharging their crops outside. And so this issue of water and your unique position of understanding how it's dosed, its nutrient profiles, I just would say, it'd be really amazing for everyone in this room to sort of like maybe tackle that as one of the key issues, because
Come on, Adi.
we've got to like use the water that's coming down out of the sky rather than these huge centralized systems that make everything very expensive.
Yeah, definitely. Oh, yeah, for sure. Yeah, and then, I guess, did everybody hear that pretty well? Or? Yeah, okay, so.
Right here.
I'm intrigued by your language, controlled environmental agriculture. That seems to be part of the problem. We keep reinventing old technology and organic practices. If I just said all this and hadn't been part of this conversation, it sounds a whole lot like a greenhouse to me. So why is it that we've abandoned greenhouses and that whole technology, and is there room for us to return to the genesis of controlled environmental agriculture as maybe seeing a pathway further toward the future for us?
Yeah, that's a good question. Yeah, so addressing sort of as far as this term controlled environment agriculture as opposed to greenhouse cultivation. Greenhouse cultivation does fall within the umbrella of controlled environment too. The controlled environment's kind of just a catch-all term that can generate from all kinds of different environmental control techniques. So even as low tech as a high tunnel or a low tunnel, all the way up to the things we're talking about with growth chambers and complete environmental control. And that kind of harkens back to what I was saying too about that is a good point. People, a lot of people are trying to leverage this in urban settings and in settings that take it away from its practice within a greenhouse too. And I think some of the most commercially successful firms too are ones who are doing hydroponics within a greenhouse too, like Rebel Greens or Bushel Bar, those ones. Yes, I think that's an important thing to remember too.
So why, again, we're always throwing the baby out with the bathwater. If technologies had stayed abreast with greenhouse management, we might not even be at this place. But we're so short-term and ephemeral that rather than looking at old technology that was pioneered by those who came before us and really trying to explore how do we expound on, expand on, engage scientists to come to the aid of their countrymen, to think in terms of how do we move that greenhouse forward. As we see, the story of Will Allen, the last remaining greenhouse in Milwaukee. Lowry Flower Shop in North Minneapolis, last remaining greenhouse in North Minneapolis. We abandoned the ship rather than stay the course. And I would urge you scientists and those of you at the university to really figure out what does that hybrid look like, where we're bringing new technology to old infrastructure.
Yeah, no, that's a good point. And something that we're hoping to work through with our lab too, and get into working through how are we designing greenhouses and things that can occupied those kind of or older spaces too, and places where they're historically implemented as well.
We're about out of time, and I know there's a couple of questions. I'd encourage you to come up and visit with Jordan afterwards, but in the interest of time, I just wanted to ask Jordan, if folks here want more information about the Controlled Environment Lab at the University of Minnesota, is there a simple, just Google that, or website, or where can they go if they want to plug in and be aware of what you're doing?
Definitely, yeah, so we're a newer lab. Currently, it's just me and my professor, Dr. Ahlens, Nate Ahlens. And so, yeah, he's still working on getting the website set up and kind of keeping a lot of this news at the forefront. But, you know, I'd say probably the easiest way to get in contact with them is to send them a message as email. If you're interested, feel free to come up afterwards. I can.
What is your email?
My email is, actually, you know, how about if people are interested, they can come up afterwards too and come and get that from me. Yeah.
And I would say too, the U of M's, the University of Minnesota's staff, if you look them up, the directory is the word I'm looking for. Pretty easy to find contact information there as well, so I'm sure you're listed there and people can find that. So with that, please help me thank Jordan. This is very, very